Okay, 2016 AIME 1, question 2. Two dice appear to be normal dice with their faces numbered from 1 to 6, but each die is weighted so that the probability of rolling the number k is directly proportional to k. The probability of rolling a 7 with this pair of dice is m over n, where m and n are relatively prime positive integers. Find m plus n. Okay, so in here, here's the idea. If they're all proportional, so the sides we have are 1, 2, 3, 4, 5, 6, and that means that I don't know the probabilities yet. There's a way I could find it, but an easy way to start off is say, okay, the probability for this is going to be 1x. The probability for this is going to be 2x, where 2x is clearly twice as big as 1x. And 3x is 3 times as big. So it's proportional to the number on there. This is the probability of each of the sides. And if I roll the die, I have to have one of these, so this probability has to add up to 1. So add, equals 1. Gives me 21x equals 1, or x is equal to 1 over 21. And that then gives me these probabilities. 4, 5, 6. So probability of 1 is 1 out of 21. Probability of 2 is 2 out of 21. Probability of 3 is 3 out of 21. I'm going to leave it like 3 out of 21 so that I can automatically have a common denominator. I could do 1/7 here. I just have to do a little bit more fraction work later on. Probability of 4 is 4 out of 21. 5 is 5 out of 21. And 6 is 6 out of 21. Same here. I could reduce this, but I'm going to have to get a common denominator later anyway. Okay, now the next thing, the ways to get a 7 is to get either 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, or 6 and 1. And the probability for getting a 1 and a 6 is 1 out of 21 times 6 out of 21. The probability of getting a 2 and a 5 is 2 out of 21 times 5 out of 21. Probability of getting a 3 and a 4 is going to be 3 out of 21 times 4 out of 21. And now, the probability for getting a 4 and a 3 is the same as a 3 and a 4. It's just a flipped order, but multiplication is commutative. So 3 out of 21 times 4 out of 21 is 4 out of 21 times 3 out of 21. 5 and 2 is the same as 2 and 5. 6 and 1 is the same as 1 and 6. So what I'm going to end up doing is I'm just going to find these probabilities and multiply through by 2 to get the rest. So you could do them all and add them all up, but this saves you a little bit of time. So 1 times 6 is 6. 21 times 21 gives me, I believe that was 441. Let me just make sure. That's a 22. 21 times 21. So 1 times 21 is 21. 2 times 21 is 42. And yep, 441. So 6 divided by 441 plus 2 times 5 is 10. We already did 21 times 21, that's 441. 3 times 4 is 12 out of 441. 6 plus 10 plus 12 is 28. So 2 times 28 over 441. I could reduce now, I can reduce later, it doesn't really matter. I'll multiply first. So I get 56 over 441. And now I know this has to reduce because 56 is 7 times 8. And 441, I got that from doing 21 squared, so it has to have a factor of 7 in it. The way I did it, first of all, is okay, I said 21 times 21 is 441. So I'm going to divide out a 7. That's the same as doing 21 times 3, which gives me out of 63. and dividing 56 by 7 gives me 8. If you didn't catch that, you could have always just done 441 divided by 7. 7 does not go into 4. 7 goes into 44 6 times. 7 goes into 21 3 times. And 8 is the only factors of 8 are, other than 1, are powers of 2, and 63 is not even. So my final answer, these are m and n, my final answer is going to be 8 plus 63, which is 71. Again, comment with any questions.